welcome back to another professional prep video. In this video, I'm going to be doing a slight recap of what we covered last week with sine, cosine, and tangent. And we're simply going to be practicing on a right triangle here. I'm going to give us a couple different exercises to give us some content to practice, because going forward, we're going to need a very fluid understanding of each of these concepts. And so doing some practice and making sure that everyone's questions are answered first is going to be really important in this process. So here I have a right triangle. I'm going to give it side lengths of 5, and then I'm going to make the hypotenuse 13. Now, I understand that we could just solve for this last side length here using Pythagorean theorem. However, I'm going to ask that we refrain from that for now so that we can get some practice improving our trigonometry skills, in particular sine, cosine, and tangent, which we first talked about last week. So let's let this angle be theta. So here's a problem. If we know that the cosine of theta is going to equal 12 over 13. And this is going to seem like a very easy problem, but I want to make sure that we have this concept reinforced. Then what is our missing side here? We'll call it x. So cosine, if you remember, is adjacent over hypotenuse. Remember, SOHCAHTOA TOA. So adjacent is x, hypotenuse is 13, and thus cosine of theta is going to be x over 13, and we know that it's 12 over 13, so there's no further simplification required. 12 over 13 equals x over 13, when x equals 12. And we know that this is true from Pythagorean theorem anyway, but this gives us some quick trig practice. And so now we know that this is 12. And so just for some practice here, let's also calculate the sine and tangent of theta. So sine theta is opposite over hypotenuse, or 5 over 13. And finally, tangent theta is opposite over adjacent, or 5 over 12. TOA. And so yeah, with that, we've practiced these three. And one thing I did want to go over, which is not related to any of these, this triangle at all, is say that we're given something like cosine theta equals to 0.4. So this is actually not something that we can do by hand typically. In some certain instances you can do this by hand, but in order to evaluate this, we're going to need a calculator, which is perfectly fine. And so essentially all that we have to do in order to evaluate this is we just need to get our calculator and simply plug this in. So in most calculators, if we're solving for theta, we can get this as theta equals inverse cosine, and that's usually written as cosine to the -1 is typically how you'll see the inverse depicted. And that's going to equal this. There we go. And so now we can evaluate this using a calculator. Hopefully you see the appropriate button on your calculator. If you do not, please contact us and we will be able to help you further with that. But when I plug this into my calculator, I get around 61.94 degrees. And so theta, this is rounded of course, but theta equals 61.94 degrees. And yeah. So we can always plug this back in by taking cosine of 61.94 and seeing if we get 0.4 or something close to 0.4. It might not be exact because that would be, we did round the 61.94, so yeah. But yeah, that is all I have for you for this video, and please join us next time, and I will see everyone later. Thank you so much. And if you have any questions, please feel free to email us. Thank you.